Hello, everybody, and welcome to today's webinar presentation, What is Cadence and is it right for you? Brought to you by Instaclustr. I'd like to introduce you to our presenter, Ben Slater. As Chief Product Officer, Ben is charged with steering Instaclustr's development roadmap and overseeing the product engineering, production support, open source, and consulting teams. Ben has over 20 years of experience in systems development, including previously being lead architect for the product that is now Oracle Policy Automation, and over 10 years as a solution architect and project manager for Accenture. He has extensive experience in managing development teams and implementing quality-controlled engineering practices. And with that, I'll hand it over to Ben.
Thanks for that intro, Lucy. Welcome everyone to today's webinar. I hope it's informative and you're ready to get going with Cadence after we're finished. Just before I get into the Cadence details, just a quick hello and an introduction to who Instaclustr is and who I am. So at Instaclustr, we're specialists in running open source software at scale, primarily through our managed platform, which supports Apache Kafka, Apache Cassandra, OpenSearch, Redis, Zookeeper, and in preview at the moment, Cadence. So we've got a strong interest in Cadence because we're going to offer it through our platform, and also it uses a lot of those other technologies that we already provide. Instaclustr has been operating since 2014. We have over 6,000 nodes under management today, so quite deep experience in managing all of those technologies that we're bringing to the Cadence space, which we've been excited to learn about. So let's dive right into what is Cadence and what's it for. And I think the best way I've found to explain that is to actually take a look at some code and talk about what benefits Cadence is providing in that code. So over on the left there is a bit of Cadence code, a workflow implementation using Cadence. What you'll probably find, hopefully, as you look at that code, is that it looks pretty much like normal code. And this example is managing a subscription. So it's if you look in the execute method there, it's sending a welcome email and then getting into a loop of waiting for 30 days and then charging the monthly fee. If the subscription gets cancelled, it sends an or it gets to the end of the free trial period, sends an email. If it gets cancelled, it deals with the cancellation. What you'd imagine a sort of fairly normal business process for managing any kind of subscription might be. And that code that you see there is really just expressing the logic of that workflow. There's very little complexity in there to deal with any failures or any of those kind of things. And that's what Cadence is allowing us to do, is to write code that reads in a very logical manner, that only really requires us to concentrate on the logic, and it takes care of a lot of the other stuff. So diving into that a little bit more, one of the steps I mentioned in there is there's a workflow.sleep for 30 days. So, basically this code is going to stop for 30 days and do nothing until it comes time to charge the next month's subscription. It doesn't take much thinking about it to understand that won't work if in a normal application. You can't expect a process to sit there running for 30 days and hope that the server doesn't reboot, or it's not necessary to do any kind of patching, or any number of things could happen, or you need to deploy a new version of your code sometime in that 30 days, and again you need to stop the process and start it again. So Cadence takes care of that for you. When you do that kind of operation like a sleep, it's saving the state of the workflow in its database, and then in 30 days time it's going to reliably restart that workflow for you at that point and allow things to continue on. And while you're sleeping, it can wait for some event to occur and wake up when some external event happens. So all of those kind of things where you need to be able to save state, and that same capability provides a lot of other benefits, such as if the server crashes in the middle of your workflow for whatever reason, or executing a particular activity, then Cadence will automatically retry that and pick it up and start it again. Also, if you need to have thousands or millions of subscriptions that you're managing at once, that gets pretty hard to do when you have to manage all of that yourself. You've got to probably do multi-threading, and at some point you need to move from multi-threading on a single instance to distributing your application across multiple instances, and all of that takes a lot of plumbing code and architectural code to make that happen. Cadence manages all of that for you. So this basic code that we see here is able to be deployed across, hundreds of servers and manage millions of subscriptions, because Cadence will take care of deploying or executing the code across those distributed servers. And then the final thing, there's really high level benefits is if you think about building this yourself, you've got these kind of subscriptions that are running for days, months, or years. Sooner or later, you're going to come across a requirement that you need to be able to look into the state of a particular subscription, see what's happened to it, where it's up to in the workflow, and all those kind of things. And because Cadence is keeping track of all of that for you, and it has a UI there to help you look into it, and an API alongside that, it's giving you that functionality for free when you're using Cadence. So in a nutshell, allowing you to focus on the business logic that you need to build and taking care of all of that complexity about making it scalable, making it reliable in the case of failure, making it able to pick up and to pause and pick up again later where that's appropriate, and just making it easier for you to build applications. So with that kind of overview of what Cadence is, just a little bit of background in where Cadence came from and where it is now. So it's an open source application, initially developed and still strongly supported and maintained by Uber. It's very widely deployed within Uber as an extremely core part of their architecture, and they've made very strong public commitments that they are going to continue supporting it as an open source application and continue to be committed to it themselves. It's open sourced in 2017 under the MIT license. MIT is a very broad open source license, one that will be compatible with just about everybody's open source policies. And it's got some really, really big, well-known users, and ones that have made public acknowledgement of their use. Uber is the obvious one. DoorDash is a very heavy user and have written a number of blogs about their use. LinkedIn, HashiCorp, Coinbase, Indeed, pretty well-known companies that are relying on this technology as a pretty core part of their architecture. And so we at Instaclustr certainly feel very confident that it's a technology that's going to be around for a while, and that's demonstrated a lot of value to a lot of pretty sophisticated technology users. So that kind of business background, a little bit of the architecture of Cadence. And so just to help orient you there, so Cadence itself is made up of a number of different services that work together. I've represented them in this diagram as Cadence nodes. We won't go into exactly what they are. You don't need to worry about too much for now. So those Cadence nodes, basically stateless, and certainly in terms of saving data, they do have some of the services have in-memory state, but no save state. They can all reconstitute themselves from the database. It does require a database to run Cadence, the Cadence service. We support Apache Cassandra at Instaclustr. We'll add Postgres later. There are other databases you can use with Cadence as well, but Cassandra probably was the earliest one, the one that's been around the longest. And then if you're using some optional features in Cadence called advanced visibility, then you need OpenSearch or Elasticsearch and Kafka as well to support your Cadence cluster. It requires access to Kafka and OpenSearch services, all of those which we provide at Instaclustr. And then your application itself is over there on the left-hand side. That's the workers. That's where your actual business logic code runs. Often those are run in Kubernetes because they are effectively stateless applications, or at least reconstitutable applications. Cadence will reconstitute them if required, and Kubernetes can be a good environment for scaling those out as your load increases and those kind of things. And then they contact Cadence via a load balancer there. So all of those, the actual workflow code and what's called the activities that do steps in the workflow are all hosted in the workers, which is code outside of Cadence itself over on the left there. So then before I dump into a bit more about how Cadence works, just a little bit about what are the signs that Cadence is a good fit for your use case and your requirement. For me, I'd kind of boil that down to, you want a requirement that consists of multiple ordered steps. If your requirement is just to do one thing, then possibly just a Kafka consumer reading off the queue, or if it's to do multiple things and that can happen in parallel and the ordering doesn't matter, then multiple Kafka consumers may well be an easier process, an easier architecture to use, and less overhead and meets that night. But if you have the multiple ordered steps, then Cadence will certainly make that easy to get those steps in order and do that. You probably want separate external interactions at the start and end of the process. So Cadence is generally not something you use, if you've got a single screen and but when the user hits submit, you want to do some stuff before it returns a value. It's more for asynchronous requirements. People have successfully guide workflows through multiple streams and those types of things, but that's still a sort of separate external interaction at the start and end of the process. I think you do also probably want to have a requirement for high levels of scale and reliability, or potentially have many requirements in your environment that are likely to fit the Cadence use case. And that's really just getting at there is an overhead to learning Cadence. There is certain techniques and experience that you need to use it successfully, and you have to be able to run the architecture unless you're using a service for that. And so to make that investment worthwhile, you either need to be getting that return in terms of the scale and reliability, the ability to do that, or just lots of uses of it. Again, will give you that advantage. And then the last one to keep in mind is although the Cadence, you'll see Cadence described as a workflow engine, it's not a workflow engine that some people may be familiar with that has some kind of business friendly language for maintaining your workflows. It is a workflow engine for developers to use to write normal Java or Go or Python code. So if your requirement is really about a workflow engine that's going to let people maintain workflow definitions in business friendly language, then Cadence is probably not the fit out of the box. There are proof of concepts around it. Is possible to write your own business-friendly language that uses Cadence underneath, and that might be useful depending on your particular use case. So some of the places that people use Cadence, order fulfillment is a good one. Where the DoorDash order, where you've got multiple steps between the consumer choosing what they want to eat and that actually being cooked and delivered to their doorstep. You can imagine with Uber being a big user, there's lots of use cases in there around ordering Uber Eats or rides on Uber. Interestingly, it's used quite a few times for infrastructure provisioning, where you've got multiple steps of, perhaps the Instaclustr example, create a VPC, create some instances within that VPC, install some software on there. Cadence can take care of those kind of multi-step processes and be very, very useful at doing that through potential failures and long time frames for some of those steps to occur. Machine learning pipelines, quite widely used for that, where you've got multiple steps and need to train models and revise the models. And I'm not an expert on that, so those types of things, but it is a multi-step process of transforming data and training your models, potentially rerunning them multiple times till you get to the accuracy that you want. And financial transactions. So it is highly reliable. It has a compensating transaction framework. Those types of things, people do use it for actual financial transactions where you've got multiple steps in the process and need to make sure that is a highly reliable process. They are just examples. It is a generic application for service for building applications. So the business applications are pretty endless. Okay, so with that, I'm actually going to switch over and walk through some code just to explain a little bit more about how Cadence works and give you a bit more of a feel for Cadence and developing in Cadence. So I switched over here to my code editor and have a Cadence workflow and activity implementation sitting here. Very, very, very basic example, not a illustrative of what you would actually do by any means, but an example, a sort of hello world example, just to give you a feel for the way it works. So what I've done here is I have, if I go right down to the main here, you'll see that I'm basically creating a workflow client. So that's the Cadence client that connects to the Cadence server. And I'm registering this current process that I'm running as being a worker. It's able to execute activities. And then I'm kicking off a workflow called my greeting workflow. And you can see that it's actually doing that by getting a stub through the Cadence client. So that means that Cadence is, that when I actually go to execute my workflow in this just here, that it's actually calling out the Cadence server at that point, which is determining what is the right worker to execute this workflow, and then executing the workflow for me on that server. So the workflow itself, you'll see, looks very similar to what we just looked at. It's kind of pretty basic code. It just calls a single activity, compose greeting, and then waits, sleeps for 10 seconds, and then returns the result, the value of that activity. And the activity itself is just concatenating two strings together. And you'll see that I've added a bunch of print statements in here just to help you see the flow of what's going on. And in fact, the results are already showing down the bottom there, but I'll run it again. And you can, I think, pretty much anybody who's done it, even the smallest bit of coding, can probably read that code and imagine what the print statements are going to say. So it's just running now. Looks like it's decided to compile for some reason. Okay, there we go. It's run now. It's executed the activity and told me the result was hello Instaclustr. And now we've hit the 10-second sleep. There we go. 10 seconds is finished, and it's finished. And return the workflow. So that's really pretty unsurprising and just doing the basic business logic that you would expect it to do. And the reason it's doing that is because it's actually all executing in this single process that I've done, and executing just like a normal program. When things get interesting is if I change this setting here when I'm setting up my new worker factory to do what's called disabling sticky execution. And that means with sticky execution, Cadence will keep a single version of the object around and just keep reusing that version as much as it can and just execute as if it's normal code as a performance optimization. If I disable this, it will pretend that, it won't just pretend it, in every step of the process, it will actually pull down the worker object and reconstitute it as if we'd had one of those 30-day sleeps or something like that. So when I run that again, we'll see what results we get out of running it. So it's going to take a little bit to compile. There we go. So you can already see it's doing something different. It's hit the 10-second sleep again. There, it's finished. So what's actually happened this time is because Cadence is recreating the object after every step in the way. So you'll see it gets to about to run the activity. And then once it goes into the activity, it's restarting the workflow again from scratch. It's about to run the activity. But the second time, it doesn't actually execute the activity. It saved the result from running that compose greeting activity in its database, and it just replays the result that second time so that it doesn't execute it again a second time, and skips on to the about to sleep. Again, once it does the sleep, it saves the result of the sleep and comes back again and runs the whole workflow again. And that ability to save the results of what's called activities, and activities are when you do like calling external services and those types of things, to save the results of doing that and then to replay those results is what allows Cadence to do that, saving, either restarting an object, restarting a workflow if it crashes, or restarting the workflow if it's necessary after it sleeps for a long time, by replaying the results of those activities and so forth. That has a couple of implications for your code. The big implication of that is that your workflow activities have to be, your workflow code has to be idempotent. Sorry, not idempotent, it has to be deterministic. meaning that, if I run it with the same set of inputs and the same set of results from my activities, then it has to follow the same code paths every time. So that means within the actual workflows themselves, you can't do things like calling external services, which one time might succeed and the next time might fail. You can't, use a random number generator, for instance, to do something, because that can return a different number every time. You have to be entirely deterministic within your workflows. Within your activity code, you're much less constrained. So when you call out to one of these activities, as I'm doing here with compose greeting, again, Cadence is getting in the middle of that call, and the activity only gets called once, and then succeeds, and then the result is saved. So that activity code can do pretty much whatever it likes within there. It can call external services. It could use random numbers or whatever. It's called once, and then the result is saved to replay later. So that's those. Once you follow that basic rule of being entirely deterministic within your workflow, then you're really just writing logical business code, and as if you would elsewhere, with a little bit of, as you saw, scaffolding in there to call Cadence along the way. And if you've ever had to write something with a whole bunch of exception handling and all of those kind of saving to databases explicitly and all those kind of things, it's not hard to imagine that there's a lot of work being saved by just being able to express your business logic in this way. So that's a very quick demo of Cadence. I only covered the very basic feature there. There are a lot of other features to learn about that Cadence provides you, such as interrogating state from running workflows, sending signals to workflows, using cron to start workflows, a whole range of things like that, child workflows that you can explore with Cadence. But that's the basic concept that you need to understand to get started, is that your workflows have to be, your workflow itself has to be entirely deterministic, and anything that you're doing that's not deterministic goes into an activity which is coordinated via the workflow. All right, great. So having had that code work through, just a final summary, I think, of the key points and sort of where to go through from here. I think that the number one thing to take away is that for many use cases, Cadence can be a significant, can significantly improve the amount of time and effort it requires to develop things. Once you've learned the basics of Cadence, there's a whole lot of things that you would normally have to worry about that you don't have to worry about anymore, that Cadence just takes care of for you. Learning Cadence itself is pretty easy. cadenceworkflow.io is the main Cadence website. If you go there, there's some Docker image you can download and get running on your environment, and there's a good selection of samples that you can easily build with instructions how to do that, and then start playing around with the samples, and you'll quickly get the hang of it. Of course, like a lot of things, you can play with some samples and get it going pretty easily on your laptop. It does get a bit more complex once you get to production operation. Also, particularly when you consider that you have a number of dependencies that you need to have there and operate, Cassandra or another database, OpenSearch, Kafka, Cadence itself. That production thing does require a bit more planning, which I guess, to give us a final plug, is where Instaclustr comes in. Through our managed platform, you can have that whole setup up and running within minutes and production ready. That is currently at the moment in preview, so contact us if you'd like access to that. I expect to be in general availability within the next couple of months. Okay, thanks for listening to the presentation. We'll now go to any questions that people might have. Okay, so the first question we have here is, what are some tips you would give someone who wants to get started with Cadence? Yeah, as I just mentioned there, the cadenceworkflow.io is a great resource for that. It's where all the Cadence documentation is and those kind of things. And I think, as I said, download the Docker images, build the samples is the place really to start. In terms of adopting it within your organization, the most successful pattern seems to be you start with a single use case within your organization, get that one done. end-to-end working, and then build from there. Build a little bit of a center of excellence within your organization with people that understand it, and then be able to help going out from there. There are a lot of places where once you start using it, you'll find there's many places that you can employ Cadence within your architecture for just about everybody. But just starting off with small steps incrementally, and building that expertise, I think is definitely a good way to go. And it looks like we have another question. How is Cadence different from a tool like Temporal.io? That's an interesting one. Temporal.io actually started as a fork of Cadence. So Cadence was the original open source project. For me, the big difference with Temporal is it is a project entirely owned by a company called Temporal, who are really focused on building their SaaS software and open source some of it, whereas Cadence is controlled and maintained by Uber, who are actual users of the software and whose motivations are to really make that software good for people to use, and trying to foster a very open community around Cadence. So to me, Cadence is much more true open source software than Temporal. Technically, at the moment, they're quite similar, though they are starting to diverge, given that Temporal is a hard fork of Cadence. And looks like one more question. What are some of the challenges of running Cadence in production? Yeah, so in general, I think most people find Cadence to be pretty stable in production. The challenges often come with the underlying dependencies, so getting your Cassandra or the database tuned, search and Kafka, and those types of things. So you need to pick those technologies that you have good expertise in, or somebody that can really help you to run those things in a really solid way. If you have those foundations really solid, then Cadence itself is generally a highly reliable application, as I said, used by some really big organizations in very key requirements. So those normal, just the normal good operations practices will put you in good stead with running Cadence itself. So it looks like that's all the questions we had for today. Thanks very much for listening. And with that, I'll hand back to you, Liz.
All right, well, DZone would like to thank Ben for a wonderful presentation. And DZone would also like to thank Instaclustr for providing the audience with a great webinar. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career.